made a mistake and pressed public instead of unlisted. But it's fine. Okay. So, guys, the test is ready now. The organic chemistry test is ready. So you can request that test. Then you write that test until when? Because Friday, yeah. Let me just say until Friday. Okay? Until Friday. Is that okay? Or let us make it this way, guys. That test this time around, I will give you that test on Friday. And then on Friday, I told you that I will not be around. So I'm going to give you that test on Friday. All of you, you write from 7:30 until 8:30 or 7:30 to 9. Between 7:30 and 9. It's a 1 hour test, but I can give you 1 hour 30 minutes. So yeah, it's 1 hour 20 minutes. Yeah. So meaning that you must write between 7:30 and that one.
Adao.
After writing, you submit. Yes, Muranda.
Test ika topic hivyo.
Organic molecules.
Okay.
Organic molecules. That is chemistry, term 1 chemistry. Okay. Now, guys, we're dealing with work today. Work, energy, and power. So, guys, this topic is divided into 4 units. The first unit is work. The second unit is work energy theorem. The third unit is conservative and non-conservative force. The last unit is power. So I'll try to summarize this in such a way that it will be easy for you to understand. But guys, this one is also just based on few concept. Actually, it's based on the network done on an object. Once you know how to deal with the network done on the object, it becomes easy for you guys to be able to manipulate all questions. Because in this one, we are dealing with the forces. Those forces in question number 2. Now, in this one, we are going to focus on energy provided by those forces in order for an object to move or to decrease the speed of an object. So that is basically work, energy, and power, the grade 12 concept, work, energy, and power. So now, I want us to define work, then we take it from then. We start by defining what is work and everything. From the definition perspective. We're going to do it from definition perspective. Then we'll take it from there. Okay? Yeah, now, what is work? Work, according to examination guideline, is just the product of, actually, examination guideline just say W is equals to F, change in X cos theta. So where W is work done in joules, F is force in newtons. Change in X, this is displacement in meters. Guys, I will share these slides after the lesson. So theta is angle between the force and displacement. Angle between the force and displacement. So that is the theta, angle theta. So we have to understand something here, guys. Let us understand this definition in ways, right? So remember, here we're talking about W. I just want to rearrange those things. Guys, I know you know this thing here. F change in X. Do you know what does that means? Is there anyone who knows what F change in X? F cos theta is. What is F cos theta?
Isn't it the magnitude?
Magnitude of what?
Your height.
I think it's the magnitude of the force applied at an angle.
That is the component of the force. Is the horizontal component of the force. Horizontal component of the force. Arekwana? That is the horizontal component of the force, guys. Okay. Hope is clear.
Sir, hello, sir. Can you please repeat it
Yes.
again?
I'm saying that is a horizontal component. And then we did the components, guys. You know, we have vertical and horizontal component.
Oh,
Fx is
oh,
F cos theta. Fy is F sin theta. These are our components. This is
okay.
horizontal component. This one is vertical component.
Oh, sure. Okay.
Yeah. So you can see that you know this, right?
Yes, sir.
Good. Now let us define this, guys. This is the product. Is the product of the displacement and the force and the component of the force parallel to the surface. So this is the definition in ways. This is the definition in ways. Definition in ways. Now, can we proceed? Yes. Let us proceed, guys. I want to show you this angle between the force and the displacement, né? Because that is another important thing that you have to know, guys. So using this scenario here, and I will also talk about the positive and negative work. So you see this force here, this displacement, let me say positive work. I will show you using positive work. Positive work is done on an object when the displacement and the force are in the same direction. So here, the angle theta is 0. Ne? Angle between the force and displacement is 0 because the two are parallel to each other. Angle between two parallel lines is 0. Is that okay?
Yes, sir.
Yes. So therefore, WF, work done by F in this case, we apply the definition. Cos theta, F change in X, here is going to be cos 0. So this is F, WF is equals to this. Therefore, WF is greater than 0. Ne? That is the positive work. Energy is transferred. Energy is transferred. Okay, then let me show you another one where we can have this positive work. This theta here is an acute angle. Our theta is less than 90. Our theta is less than 90. Therefore, work done by F is F change in X cos theta, which is less than 90. So cos of theta will be greater than 0 in this case if our theta is less than 90, which will result to this one being greater than 0. Ne? That is positive work. Let me show you another one. So that force over there. So work done by this force is F change in X cos theta. As long as theta is less than 90, then cos theta will be greater than 0. Hence, WF is also greater than 0. Guys, any question? Any query? No question. So we are all fine. Because guys, we must move together. We must move together to that distinction. Okay, in view of that, let us move to the next slide. Remember, we'll share the slides after this lesson. So in the next slide, I want to show you the zero work, negative work, sorry. Negative work, showing you the angle between displacement and the force. Number one, okay, let us look at this one here. This is the force, and the angle between force and the displacement is 180. Theta is 180. So let us go straight to the formula. WF is equals to F change in X cos theta. F change in X cos 180. This is negative F change in X. Therefore, WF will be less than 0. So guys, FK, let me have this conclusion. FK is always at 180 degrees. Therefore, it does negative work. It does negative work. So frictional force is always like that. Né? It's always at 180 degrees. And it does negative work. So like, even if you have something like this, let me just show you this one, the last one, guys, before we can move to another segment. 2. this object is displacing to the left, but a force is applied to the right. The two are in opposite direction. Therefore, here we're going to have the angle between is this one here, which is 180 minus theta. Okay. Work done by F is equals to F cos 180 minus theta. Cos 180 minus theta is negative. Is less than 0. Therefore, this WF will also be less than 0. It will also be less than 0. Any query?
Madam,
Yes.
ndakumbura riba doborore the second one.
Yeah. The second one is we are saying that here is the straight line. From here to here is 180. But where is our force? Our force is here. Meaning that if we subtract this is the portion that we're looking for. So if you subtract this theta here, so 180 minus theta, this is our angle. And using the trig ratio, the fact that we get from trig ratio, we know the cos of 180 minus theta is negative. Hence, we are even work done less than 0. For any acute angle theta, the thing will be negative. Guys, are we fine?
Yes.
So can I show you what do you call this? Can I show you what is this again? I want to show you something. Zero work, guys. Number 3. Zero work. Then we do some examples. Ne? When do we say zero work is done? Zero work is done by a force that is applied at 90 degrees to the displacement. You see that force? Work done by that force is equals to F change in X cos theta. What is the angle between displacement and F?
Isn't it
What is
90?
the angle between? Come again?
Is it 90?
It's 90. Good. That is 90. It's 90. So cos of 90 is there. Ne? Cos of 90 is there. Okay. Now let us have this conclusion. Work done by normal force is always 0. Work done by normal force is always 0. Ne? Work done by gravitational force is 0 on a horizontal plane. On a horizontal plane. because you know normal force is always actually on a horizontal plane is always perpendicular to, actually it's always in the opposite direction of the FG, and precisely FG perpendicular on an inclined plane. The non-horizontal plane is FG, like that. Okay, so this is our conclusion. So before we can do some examples, do you have a question? Because now I want us to do some examples. Okay, I think you are agreeing with me to say, let us do some problems here. Let us do some problems. Let me check this one out, if it's okay. This one is very much okay. All right. Yeah, I have a problem. I have a problem that we must look at, but I think I must edit this one because it's not giving what I want. It's not giving what I want. So as a result, I must look at it. Okay. Okay, it's just an example. So then we take it from there. Calculate the work done by each force. Calculate the work done by each force. Let me load the problem. I will just do maybe one, then you will do one, so that you can be busy. Let me just send that one. Okay, yeah. Yeah. Work energy. Work. Tigo akamizi. But I know that I will win. Always win because I'm a winner. I will always win, guys. Thank you. When the other device is not working, we go for another one. Because the one that I'm using, guys, is misbehaving. It's not making sure. So, but guys, this is the definition of work. No? The most important thing that I'm going to do is coming. But I cannot do that part without even looking at some application. We have to do some application. Then after application, we can quickly uh, look at this one. Okay, yeah. I have this one here. I'm just taking it from your book, which is the book that is written by Olivia. I prefer that one. Yeah. Yes, you're going to do this one. Yeah, I've won. As I told you that I always win, guys. I always win. I'm like Kaiser Chiefs. These days, Kaiser Chiefs is winning. And Mamelodi Orlando Pirates is misbehaving. Yeah, yeah, it is, guys. Sorry for taking time, but it was for a good cause. It was for a good cause. Why is it not coming? The thing is now showing me flames. Okay, thank you. Thank you. Yeah, here's the example that I want us to do. We have 1, 2, 3, 4, 5. We have 5 examples. So we're going to start with 4.1. Or we can do it here. Ne? W equals to F change in X cos theta. So our F here is 50. 2 cos 0 displacement, and that one is going the same direction. The answer is 100 joules. 100 joules. So can we move to the next one? Next one. Thank you. Now, same formula, F change in X cos theta. So the angle you can see is 90. Ne? That is 50 times 2 cos 90. The answer is 0. Meaning that is doing negative work. Ne? I mean 0 work. 0 joules. Then let us do 4.3. 4.3. 4.3. You can see displacement and the force are in opposite direction. WF change in X cos theta. So our F here is 50. We multiply this by 2 cos of 180 because they are moving in opposite direction. The answer is negative 100 joules. Some energy was lost. Energy added is positive, energy lost is negative. Then 4.4. 4.4. Same formula. It's still 50. That is 50. Let me answer this all again. Okay, that is cos what, guys? It's cos 40, ne? Can I have the answer? This one I don't know the answer. But I know it's less than 100. That is what I know.
It's 76,60 joules.
76.60 joules. Thank you. Then, yeah, the last one. W, if you check, this one is in opposite direction. It's in opposite direction. So cos theta. For this one, we are going to have, because if you are to draw a free body diagram so that you can see this one nicely, so this is the normal force, this is the weight, this is the force, this is 40 degrees, this is displacement. So you can see where it's 180, working at an angle of 90 plus. That is the angle that is given. Okay, but it's fine. Let us use that one that is given, 90 plus 40. 90 plus 40. I don't know the reason to say 90 plus, but we can't have something like that. That angle is 180 plus 40, not 90. So the examiner here flop, or the writer flop. But anyway, let us use his angle. The answer will still be negative, né? Oh, F is 50, sorry. 2 cos of 130 negative
64.28 joules.
28 joules. So that is the work done by that force. Work done by that force. So we have done different scenarios here. So guys, I want you to try this one. I want you to try this one. I'm giving you only 10 minutes, 10 minutes, you try this one. Then we mark. You are writing now. So time, 10 minutes start now. 3 minutes left. Three. Let's wrap it up.
Uri umaliwa nende zimene yava achikupfana nayo yalilesa ende ine zvikumuvayisa ngori uri hula married men uyamufuna vayafunana ende una vutanzi nazvo zvahadivi uri aitemi ati aripe xitori ndimasiya rothe ine ndi mudzana wa 24 years currently ndipitori nga chikoro but haya ndibva western ndina problem ya uri ndina married man ine ndadzvira nayo this year nga april ri kufara 6 years rirode. The wife doesn't know anything. To cut the story short, mujolo wanga na huyu munna wova serious because nenda ndichiva ndivhen ene angene pitori ndichivonana zvesvo ovuya nenda ndina boyfriend haya nendambodziva pregnant married man akwadza then ndabhebha after a few months amufarira kuchiro haya pano ava enewo kutogomera mwana achiita zvose baby titi asaicheni rambodziyirwa nababy titi nga 2023 mwana ova onova na 2 years rarukisa nababy titi then baby titi ova achikunetsesa vazana achichola nendaneta gautwa ndikurwa naye ndapakaya nga 2024 ngaDecember obva kai ka 2024 ngaDecember okay guys naginyo phone iwa
Okay, guys, I think time is up. So are we done? Can I see your reactions? Yes, Mavi, you are done. So you okay? Thank you. Thank you, 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 thank you. Good. Let us do correction, guys. It says that we have a block of ice with mass 5 kg to the right at constant velocity of a friction-free surface AB. So with a distance of 4 meters, when the block reaches rough part BC, a constant force 6 newtons is applied to the block so that it keeps moving at constant velocity over a rough surface for a distance of 3 meters. Draw a free body diagram to indicate all forces exerted on the block Y moving across frictionless surface AB. Here's the free body, guys. We have the normal force. We have the weight. What else? No other force because it's just frictionless. It's just frictionless. Okay, two forces. Can I see those who got it right? Those who got it right, thank you, thank you, thank you, thank you, thank you, thank you. Thank you, ladies and gents. Now, which of the movements over AB and BC did work on the block? Which of the movements? Which forces for the movement over AB and BC did work on the block? Explain your answer. Can I have the force? Can I have the force? Which force? AB. Do we have a force on AB? Do we have a force on AB? Or guys, you can see a force on AB that does the work. Talk to me. Anyone?
Applied force.
We don't have applied force according to a free body diagram. Okay, on which side? And yeah, you're right. But we must also look at which side are we talking about here.
The first block.
Which side are we talking about?
On the right
AB,
side.
AB, BC, BC.
Has an applied force, but not AB.
There's nothing on AB, ne?
Yes,
Yeah, so there's nothing on AB. Hence, we look at BC, guys.
So we skipped 6.2.
Oh, 6.2. Sorry. 6.2, draw a free body diagram. It's normal here. It's weight here. is applied here and is frictional force. All these forces, applied force and FK, they are doing work. Ne? So which of the forces for the movement over A, B, and D, B, C did work on the block? Of course, it's FA, applied force, and FK. The work done, the reason that we can give, you can say the work done by these forces is not zero. Ne? The work done by these forces is not zero. Okay. Or we can also say they are parallel to the displacement. Ne? But remember, a F net, it does no work. Ne? F net is zero by these forces, meaning that they are equal in terms of magnitude. They are equal. Okay, let us move to the next one. Which forces for the movement A, B, and BD did not do any work on the block? N, normal force, and FG. They are acting perpendicular to the acting perpendicular to the displacement. They are acting perpendicular to the displacement. So then we are asked to calculate work done by each forces in 6.3. That is work done by applied, which is F, change in X cos theta. Our F here is 6 newtons. Multiply by 3, cos of 0. The answer is 18 joules. Then the last one, work done by FK. FK, change in X cos theta. Our FK, what is our frictional force?
6.
Very good. They are equal because it's moving at constant velocity. Ne? Cos 180, the answer is negative 18 joules. Can I see those who got it right? 6.5. Fourth. Good. Guys, it's not just the matter of saying fine. Okay. But anyway, let us proceed. I hope this one, it was also not difficult. Now, guys, we have done an introduction here. Now, I want to show you the most important thing that you have to know. I am going to show you, let me say 3, only 3. Going to show you the first one, the second one, the third one. Then I show you 2 on an inclined plane. 2 on an inclined plane. So if I can show you this one, then we have done the work. So, and I would like you guys to be proactive. Yeah. What I want us to do is the network done. Network done, guys. We are going to look at the following. We can use work done by each force, or we can use the Fnet. Okay, let us start by work done by each force on this first case. A force is applied in this fashion to display this object x meters. So let us draw a free body diagram. Free body and force diagram. Something that is free, that body is free. So mobile wa mahara, free body. Showing all forces acting on that one. We are going to have normal force. And this one is a body. So the mobile wa mahara, free body. We have the applied force. We have the frictional force. We have the frictional force. Then let us draw a force diagram. For force diagram, you draw a box. Then your normal force from the surface. This is the normal, your gravitational force from the center. And your what? Your applied force and your frictional force on the surface. So guys, these are our forces. These are our forces. So let us calculate the work done by each force. Remember, we talk about normal force and FG. Ne? Work done by normal force is 0. Work done by FG is also 0. It's also 0. Now, let us deal with work done by F. Is F change in x cos theta? Work done by FK. Or basically this one, it will go to F. What is the angle here? It's 0. Ne? Displacement and force. We're going to end up having this one. Then let us look at work done by frictional force. Fk change in x cos theta. Our Fk cos 108. The answer is negative Fk change in x. Then, ladies and gents, let us do the work net. Work net is equals to work done by F, work done by Fk, work done by normal, and work done by Fg. So this is our F net, ne? Our work net, sorry. Then you can come and substitute. Work done by F is F change in x. By Fk is negative Fk change in x plus 0 plus 0. If you take out change in x here, you're going to have this change in x. So this is the same as F net, eh? This is the same as F net change in x, you see? Now, guys, if you don't want to use this, therefore, if we have F net, we can just say F work net is equals to F net change in x cos theta. So this theta here, it must always be 0. Check here. It's our guiding problem here. Then we're going to, if we define F net here, we define only forces acting parallel to the surface. So that is F minus Fk. change in x cos of 0. This is F minus Fk, change in x. Then we are done. Any question? So if you are getting it, you know what to do. Is this clear? Okay, Singosh saying aye, fine. Good. Mulweli. Mulweli miyani nakho mbuso rini Dari ni attend. Vamba suzvinji. Hey, you must talk to me. Okay, thank you. Lifa. Mulweli, are we fine? Mularo? Hey, when am I dandila? Ronnie, Tendi, Una, guys, if you are lost, you must tell me so that I can explain. Because here we're dealing with the most important. You understand this, then the whole topic is easy for you. So can we move to the next one? Rear mover. Okay, good. Let us move. Let us move. Let us move. Let us move. Look at what I'm doing here now. So I just changed the angle now. That force is applied at an angle. So if it's at an angle, even here we're going to change. Ne? We're going to change, even here we're going to change. Everything will remain the same. Except here. So here we are changing, guys, because this thing here is just F changing X cos theta. F changing X cos theta. So the frictional force, it will never change. It will never change that one. So work done by normal, it will still be that one. Fg, it will still be that one. So, but here we're going to have a different story. Ne? We are going to have a different story. Work done by F is F, change in X cos theta. Negative Fk, change in X. So if we take out the common factor, change in X, we're going to have F cos theta minus Fk, change in X outside. Can you see that we are going back to this defining of F net? Okay, let me show you if we were to use this formula here. Work net is equals to F net. F net change in X. So let us define F net. When we define F net, we redraw our free body diagram including components. So we're going to redraw it here. Normal, weight. This is the applied. At an angle, you have your frictional force. Now, this one, it has a component called Fx and a component called Fy. So when we define F net, we define F net here. Forces acting parallel to the surface. fx minus fk. Change in x cos 0. Then fx is f cos theta minus fk. Change in x. Guys, can you see that this one is the same as this? Né? These two are the same. Therefore, it depends on which method you want to use. But everything is the same. Everything is the same. Guys, are we happy? Li happy na? Okay. Okay, because here we're dealing with sensitive part. Né? Then the last one that I want to do with you, I said I'm going to do 3. Né? The last one is this one. We are changing everything now. Here is the force. We are definitely going to change the diagrams. Né? Obvious is the lunch bar. Here. And this one is F. So let us change going down. So this one, it won't change. This one, it won't change. Everything here, it was not going to change. Except the fact that now normal force is equals to Fg plus Fg perpendicular. So guys, this is it. Nah? There is nothing much here that I can do. Everything is the same. Everything is the same. Okay, any question before I show you the inclined plane? Or should we do this first? Yeah, let us do this one before we can do incline. Let's just do this one before we do incline plane. Inclined plane, inclined plane. Horizontal plane, but that is dealing with the network done. Okay, we have this one here. The one for you guys. Okay, guys, here is the two problems that I want us to do before we vamos. Before we vamos, where is that one? Okay. Before we go, I want us to do these two problems, guys. And I will add another one. So let us start by this one. It says that Linda applies a force of 120 newtons to pull a crate of mass 50 kg over a distance of 5 meters. Horizontal surface. Calculate the net work on the crate if Linda exerts a force of 120 newtons horizontally to the ground on the crate. So, meaning that we are going to assume that the surface is frictionless. No? The surface is frictionless. So, if that is the case, then 2.1 work net is equals to work done by F. Work done by applied, because the one for normal, work done by FG, work done by normal. So let us start. Work done by F is F change in X cos theta. So this one is 0 and 0. F is 120. Change in X is just 5. Cos 0. Why cos 0? Because they are saying horizontally to the ground. Ne? Horizontally to the ground. So what is 120 times 5? Okay. Then what is the answer? 120 times 5. 120 times 5.
600.
600 joules. That is the network done. And 2.2, calculate the network done at an angle of 8. Now we are changing the angle. Work net is equals to WF plus W normal. WF is F change in X cos theta plus 0. So F, our F here is 120. Change in X is change in X displacement. It's 5 meters. No? Cos of 30. What is the answer?
519,62.
0.62 joules. So this is our work net. As we are changing the angle, then guys, there is this one here that I want you guys to try. In just 10 minutes, then we are done. 10 minutes, we are done. We are all writing. How far? How far? How far? Because guys, you have only 2 minutes. Finish up. Yeah, guys, I think the time is up for you to write. So let us get to the business and see if whether you are following. So I hope you are done. Can I get a confirmation? Confirmation. Then we work this one out quickly. Single done, Andy. Patience. I hope you are not patience or Zokor. You know patience or Zokor.
Yes, sir.
Okay. Yeah, let us do this one, Lifo. It says that Jackson applies a force of 300 newtons to pull a crate with a mass of 40 kg across a distance 8 meters over a rough horizontal floor with a kinetic force of frictional force of 50 newtons. Draw a free body diagram showing all forces acting on the crate. This is the free body diagram that you have drawn, guys. Normal force, Fg,
So they said horizontal forces only.
horizontal forces only.
Yes.
Thank you, patience. This is Fx and Fk. Né? is Fx and Fk, guys. These are the only two forces acting. Calculate the net resultant horizontal forces in 4.1. F net is equals to Fx minus Fk. This is F cos theta minus Fk. Let us substitute our F. 300 cos 30 minus 50. What is the answer?
Or 9,
209,
81.
81 joules. 209,81 joules. Okay. 4.3. Calculate the network done. Oh, it's not joules, guys. It's newtons. It's newtons in the direction of the motion. So work net is F net change in x cos theta. Our F net is 209,81 multiplied by 8 cos of 0. And the answer is what is the answer?
1,678,48.
Come again.
1,608.
Comma
1,678. Comma 48.
comma 48 joules. That is the work done. Work done. So network done. So draw a free diagram of all the vertical forces acting on the crate while it is being pulled. Normal force and FG. The next question, calculate the network done on the crate by all vertical forces on the crate. Work net is equals to Fn minus Fg. Change in x cos theta. So our Fn in this case is what? Is not just mg, but it's mg minus fy. Mg minus fy. Mg minus f sin theta minus fg in brackets change in x. And fg is just mg. Né? And that mg goes out. We are left with f sin theta. So I wanted to check something. So it's not giving us that 0. I want to prove if whether it will give us that 0. Né? So, but you are dealing with these forces. The angle here is not that 30. The angle is not theta. The angle of FY, because this is what we're having. Then we're going to have our FY here. So the angle is 1/8. The angle is 1/8. So M, guys, this one and this one will cancel out. And we are left with this one, F sine theta, change in X. So this negative F, oh no, let us substitute. Our F is that force. That force is going to give us what? F, which is 300. 300 sine if you say sine 1/8, this thing here is going to 0. So to avoid just doing this, guys, let's just conclude. Ne? And we know Fn and Fg are equal. Work net here is 0 because work done by normal and work done by Fg is 0. Ne? It's like saying, let us do this. Let me show you. Work done by normal, work done by Fg. This is 0 plus 0. The answer is 0G. So confirm your answers in 4.3 by calculating the net work done on the crate by using algebraic sum of work quantities of all forces. Okay, we just have to confirm that 4.3 by doing this. Work done by F is equals to F change in X cos theta. So guys, our F is still 300. Change in X here is going to be 8 cos 30. What is the answer? What is the answer, guys?
2078,46.
2078.
Yes, 46.
Number 46. And here 50 times 8. 50 times 8.
300. 346,41.
41. Then from here, we do work net. Work net is cost work done by F plus work done by FK. Work done by F is 2078,46 plus negative 346,41. Is this not 1678,48 joules? Okay. So, guys, do you have a question? Any question? So, any question? Addition, subtraction, we are all fine. If we are all fine, we know what to do. So far, I'm really single. Zoom user.
Badau.
Good day. Yes, for single.
Apononi bori 2078,46 plus negative 346,41.
Yeah.
Tiri bori ndi calculator yanga na mara nendo wana 1732,05.
1,000.
732,05.
32,05.
Sir, problem here for 50 times 8.
50 times what?
It equals to negative 100.
It's negative what?
400.
Negative 400. Okay, thank you. So by change, asiyona. So it's negative 400 joules. Then here we're going to have negative 400. So from here, what will be the answer? Is it
Yeah,
1678?
Yes.
Same, nah?
Yes.
Okay. Then we are done. So guys, there is this one, but this one I want you to do it offline. You're going to do this one and submit. Where is that problem? Where is that problem? The problem is here. Okay, you are going to do activity number 1. Activity number 1, guys. Activity number 1. I know we haven't touched the work energy theorem, but I want you to try. Activity number 1 in this booklet here. You are doing activity number 1 from that booklet. So, guys, we are done for today. We are saying that the test is when? When is the test?
Friday.
Friday, 7:30. So, organic molecules. Same time. We are writing same time. So, we don't want to hear stories. So, guys, let us stop here for today. And if you have any question, don't hesitate to send it to me so that I can assist you. Nah? But for now, let us stop here. See you. Guys, don't forget tomorrow we are doing electric circuit, nah? Internal resistance. We're still on internal resistance. We're going to do tutorials on internal resistance tomorrow with grade 11. So if you are not attending any lesson, please do attend. Same time, same place. Shalom.